Hello guys, welcome back to FreeCodeCamp. We're doing learning recursions by building a decimal to binary converter. We're on step 56, and this is part of the JavaScript algorithms and data structures. If you guys do find it helpful, please subscribe and like the video. So for step 56, it says now we'll create a function that will count down from a given number to 0 using recursion. So we're going to create a new function called countdown with number as a parameter. And we could leave the function body empty for now. So in order to do this, I want to create a function called countdown, which is going to be having the parameter of number. So inside the parentheses, you could have number as a parameter. And for now, the body will be empty in between these curly braces, just like this. So now for step 57, it says the first thing we need to do is log the current value of number to the console to act as the countdown. So we're going to use console log to log the number to the console. So we're inside our countdown function we created last step. Inside the body, we're going to do console.log and number. And this number is referring to the parameter. So a recursive function is a function that calls itself over and over, but we need to be careful because it could create an infinity loop. All right. So since our countdown function will count down to a given number to 0, the base case is the number parameter is equal to 0. So this should return a breakout of the recursive loop. So we're going to use the if statement to check if the number is equal to 0, and if it is, we're going to use the return keyword to break out the function. So still inside the countdown function under the console log, we're going to do a if statement just like this with the if and then parentheses, and we're going to check if number is strictly equal with three equal signs to 0, and the three equal signs checks for the value and the type. And now we just and we're going to also return use the return method to break out the recursive loop, to break out the function, I mean, just like this. Now we'll just wait for this add. Okay, so now for step 59. So recursive functions also have a recursive case, which is where the function calls itself. First, we want to convert if statement into an if else statement and leave the body of our else statement for empty now. So first we're going to convert our if statement to an if else. So if else, oh, I'm sorry, not like that. It'll be if and then else, just like this. And we're going to leave the else body empty for now, just like this. So now step 60, it says when writing recursive case, you will need to remember two things. What is the base case and what is the least amount of work you need to do to get closer to the base case. So since the base case is when the number is equal to 0, we will need to call the countdown again while also lowering the value of number by 1. So inside the else block, we're going to count down, we're going to use the countdown function and pass it the number minus 1 as the argument. So inside our else, so if the number is not equal to 0 yet, we are going to call the countdown function that we have, just like this, and we're going to pass in number minus 1. So this will just count down. So we'll just lower the value of number by 1. So now for step 61, it says it's time to test our function. We're going to call the countdown function as our argument of 3 to see if this works. So we can do countdown, and we're going to pass in 3, and this 3 will be the number over here. So it's going to count down. It should be counting down 3, 2, 1 until it hits 0, and then this function will end. Now I'm going to open the console as well, and we do see 3, 2, 1, 0. So now for step 62, it says to really see the call stack in action, we need to modify the function slightly. So we're gonna rename the countdown function to countdown and up countdown and up, and also update the function call as well. So we have this countdown function. We're gonna just rename it to countdown and up. Make sure you're using camel casing, and then this call that we have, we're just gonna replace it with countdown and up, just like this. Oh, and we also have this previous countdown, which is now countdown and up, just like this. So now for step 63, it says in your base case, log reach base case to the console. So we could do console.log and then string reached base case. And then we're going to log number to the console after the recursive countdown and up, which counts if the which decreases the number by 1 function call. So after this, we could just console.log number. It says for step 65, it's now we should see the countdown 3, 2, 0, which we do, followed by reach base case, and then a countdown, then a count from 1 to 3, which we do. Then this is because after the recursive function is finished, the function will continue to execute the code after the recursive call. This is when you see the reach base case before the countdown before the count from 1 to 3. All right, to now better understand the call stack and recursion work, we're going to refactor our decimal to binary function to use recursion instead of the while loop. So first we're going to remove our countdown and function and all the calls. So we just remove everything from line 5 through 17. And now we're going to remove the content of our decimal to binary function, and we're going to leave the body of the function empty for now. So inside our body, which is inside the curly braces, we're just going to remove everything until we reach the closing curly braces. And now this is our empty body for our decimal to binary function. So now for step 67, as a reminder, it is often best to start with the base case when we're writing a recursive function, so we know what we're working towards and to prevent infinity loops. So similar to our last implementation, we'll divide input by 2 and repeatedly until input is 0. So we're going to use the if statement to check if input is equal to 0. So we're inside our decimal to binary function, and we're going to do if input is strictly equal to 0, then we're just going to do return. And then we're just going to return an empty string. Just like this. Oh, it should be return empty string. And now we're going to add an else statement and return the result of calling decimal to binary and pass in input divided by 2, rounded down with math.floor as the argument. So after the if, we could write an else. So if input is not equal to 0, we will call the decimal to binary function, just like this. And we're going to pass in input divided by 2, and this should be inside a math.floor method. So it should be math.floor and then parentheses, and inside these parentheses we should have input divided by 2. And oh, it should return. So return in front of our decimal to binary. So now for step 69, so this lowers the input roughly by half each time the decimal to binary function is called. However, remember the binary number string is built by calculating the remainder of input divided by 2. So after our call to the decimal to binary, use the addition operator to concatenate the remainder of the input divided by 2 to the end of the string. And also wrap the operator in parentheses. So it says after the call to the binary to decimal or decimal to binary function, we're going to use the addition. So after we do call this, we do plus. We're wrapping in parentheses. And so the remainder of input divided by 2 to the end of the string. So we could do input divided by 2. It says you should use the additional operator plus to concatenate the remainder of input divided by 2. So maybe we should remove Alright, let's console. Let's go back. Step 68. Oh, we were not on step 68, we're on step 69. And we're going to restart this. So after our call, we're going to use the additional operator to concatenate the remainder of input divided by 2 to the end of the string of our recursion. Maybe you could just remove this input. Actually, we don't want to do that. Maybe add a plus. Input divided by 2. So let's see. And we're going to restart this lesson. And this should be, oh, because it wants us to see what the remainder is. And we could maybe do plus input module 2, and this will give us the remainder. Yes, it does. So now for step 70, it says finally in our check user input function, set the text content property of result equal to the string returned by our decimal to binary function. So inside our check user function, we're going to set the text content of result so result is equal to decimal to binary function, just like this. Let's see what is up over here. So I'm gonna restart this lesson. Okay, so finally we're gonna check We're gonna set the text content property of result. So let's do that first. We'll do result dot text content, and inside here it should equal to the string returned by our decimal to binary function, which is going to be equal. So we can do equal decimal to binary, just like this. Okay, that was it. So now for step 71, you can find it in my next video, which should be coming out tomorrow. And I hope you guys did learn. Please subscribe and like if you found it helpful. Thank you.